In this question, we were asked to turn 3 sine 5x plus 4 cosine 5x into a single sine function. And to do that, this is the form we're asked to put it in, so a sine bx plus c. To do that, we're going to use the sum expansion identity for the sine function. And that means we have a, let's do this a little bit smaller, so a times the sine of alpha, which is our bx, cosine beta, which is our c, plus sine of c cosine of bx. And so that's what this is equal to. We also want 3 sine 5x to equal that as well. So before I start with that, I'm going to multiply or distribute a through. So we get a sine of bx cosine of c plus a sine of c cosine of bx is equal to our 3 sine 5x plus 4 cosine 5x. The bx has got to match the 5x here. So that means when we have this bx right here and this bx right here, those need to match the 5x's. So we can replace b with 5x. So let's do that. 5x, 5x. Now c is going to be a constant. It contributes to how we find the shift of this function when we want to graph it. So that means that we have a coefficient in front of our sine function of a sine of c. Excuse me, in front of our cosine function. And then we have a coefficient in front of, well, we can make it in front of our sine of 5x of a cosine c. So let's rewrite this. A cosine of c times the sine of 5x plus a sine of c times the cosine of 5x. And that's equal to, in this case, on the right-hand side of the equation, we have a coefficient of 3 in front of our sine 5x. So, and we have a 4 in front of the cosine term. So, with green, I'm going to write 3, then black, sine of 5x plus 4 cosine of 5x. So that means that in front of the sine function, we have a cosine c on the left-hand side. On the right-hand side, in front of the sine function, we have a 3. In order for the left-hand side and the right-hand side to equal each other, the sine terms have to equal each other. So we already have the sine of 5x are equal to each other, but we need a cosine c to equal 3. Now we have a sine c in front of our cosine term and 4 in front of our cosine term. So in order for the left-hand and the right-hand side of the equation to equal, we need a sine of c to equal 4. At this point, we can solve for our cosine function. So we have the cosine of c is equal to 3 over a. And if we think about this, when we first learned about circles and the cosine function, this right here was the x term, and this right here was the hypotenuse, or the radius of our circle. And doing the same for the sine of c, we get 4 over a, and this was our y term, and this was the radius of the circle. So drawing our circle, both our x term and our y term are positive, so we're in the first quadrant. So we have a 3 here and a 4 here. Let me make that prettier. So we have this right triangle here. And this angle right here is our C. And our hypotenuse is A. So if you're in my class, you might recognize this as a 3, 4, 5 triangle, which happens to be a Pythagorean triple. But if not, then you know that we can use the Pythagorean theorem on this right triangle to solve for A. So we know that 3 squared plus 4 squared equals A. Or 9 plus 16, a squared. 9 plus 16 is equal to a squared. 25 is equal to a squared, or a is equal to 5. Because this is a radius of a circle, a is always positive. Now, our angle C, we have the adjacent side and the opposite side. So that means we can take the tangent of C and say that's equal to 4 over 3, or C is equal to the inverse tan of 4 over 3. Anytime you take an inverse trig function, you have to make sure that you have adjusted for being in the correct quadrant. Now, with the inverse tan, we get values between negative pi over 2 and positive pi over 2. If angle C lies between negative pi over 2 and pi over 2, there are no adjustments necessary. And in this case, because the angle is in the first quadrant, we have no adjustments to make. So that means C is the inverse tan of 4/3. A is 5, and we now know B, and we knew B was equal to 5. So 3 sine 5x plus 4 cosine 5x is equal to 5 times the sine of 5x plus the inverse tan of 4 over 3. And so this is in its exact form. And if you were going to do anything further with it, this is how I would leave it. What if we had negative 3 sine of 5x plus 4 cosine of 5x, and we wanted to write it as a sine of bx plus c. Now, a cosine c sine, since our bx is 5x, plus a sine of c times the cosine of 5x is equal to a sine bx plus c, which is also equal to negative 3 sine of 5x plus 4 cosine of 5x. So one of the biggest things that we now have to do is, so now what we do is we find our values that need to be the same. So a cosine c needs to equal negative 3. a sine c needs to equal 4. Now we collect the things that have to be the same. We have a sine of c. A cosine c is our coefficient in front of the sine of 5x. So negative 3 is the coefficient in front of our negative sine of 5x, which means that a cosine of c has to equal negative 3. In front of our cosine term, we have a sine of c. And on the left-hand side, on the right-hand side, we have 4. So that means a sine of c has to equal 4. Now, the triangle, so we're going to have the cosine of c is equal to negative 3 over a. So this is our x-coordinate, this is our hypotenuse. And then we have the sine of c is equal to 4 over a. This is our y-coordinate and our hypotenuse. Drawing that in, we have negative 3 and a positive 4. So that puts us in the second quadrant. And this slope, when you're moving from left to right, is negative. So this is our angle C. C is in the second quadrant. C in Q2, quadrant 2. This is negative 3. This is 4. So still, because these magnitudes are the same, A is equal to 5. The only thing that we need to worry about now is the tangent of C is equal to opposite 4 over adjacent negative 3. Now, the inverse tan will give us values between negative pi over 2 and positive pi over 2. So the value, once we inverse tan of 4 over negative 3. Now, the problem with that is, because of the way the inverse tan is defined, that gives us a fourth quadrant solution. So this angle right here is the inverse tan of 4 over 3. And that is not what C is. In order to get to C, we need to add pi to that angle, plus pi. So that means we need to add pi to the inverse tan of 4 over negative 3 to get to C. So that means our negative 3 sine of 5x plus 4 cosine of 5x is equal to 5 times the sine of 5x plus the inverse tan of 4 over negative 3 plus pi. The only difference between this solution and the last solution is this shift, because we need the shift to get us into the second quadrant rather than the first quadrant.